All right, folks. Nobody requested this video yet, but I do want to take the time to make it. It's AP style question 1. So this is on the back of the sheet you picked up on Friday. I'm going to make a video of part C because I think that's a particularly tough part, and I do want people to take some time to understand that. So it says discrete random variable y is calculated by taking the sum of two occurrences of random variable x. We look at our graph. This is the graph I drew on the board, and it clearly shows that random variable x can either be 1, 2, or 3. So if y is the sum of x, sum of two x's, then y could either be a 1 and a 1. Like I could get a 1 the first time for x and a 1 the second time. I could get a 1 the first time for x and a 2 the second time. I could get a 1 the first time for x and a 3 a second time. I could get a 2 the first time and a 1 a second time, a 2 the first time and a 2 the second time, a 2 the first time and a 3 the second time, 3 the first time, a 1 the second time, 3 the first time, a 2 the second time, and 3 the first time, a 3 the second time. Each of these, call it trials, right? Because this would be one trial, right? I get a 1 and a 1. This is a different trial. I get a 1 and a 2. Each of these trials gives a different value for y. Remember, y is just the sum of any two x's. So that means, let me write this in here, excuse me, that for this case, we have that y equals 2. For this case, we have y equals 3, y equals 4, y equals 3, y equals 4. Because remember, y equals 5 here. Y is just the sum of the two x's. Y equals 4, y equals 5, y equals 6. Let me erase this for the temporary time. So now I can calculate what is the probability of each of these 9 trials happening. There are 9 possible trials. Well, the probability of this is saying that what is the probability I draw a 1 and I draw a 1 the second time. So I draw a 1 the first time and I draw 1 the second time. The reason I'm enunciating and so much is because I want you to think and means multiply. The probability of drawing a 1 for x is 0.2. It shows that in the graph. The probability of getting a 1 is 0.2. So the probability of getting a 1 and then a 1 again would be 0.2 times 0.2, 0.04. The probability of getting a 1 is 0.2. The probability of getting a 2 is 0.5. This is all from the graph. So that means the probability of getting a 1 and a 2 is 0.2 times 0.5, so 0.1. The probability of getting a 1 and a 3 is the probability of getting a 1, 0.2, times the probability of getting a 3, 0.3, which is 0.06. And I go through and I do that for each and every combination. I find the probability for each combination. If you want to verify that you're right, you can add all these probabilities up, and I get 1. You should get 1, because these are the 9 possible outcomes for drawing two x's. So now I'm going to say, well, what are the possible values for y? Well, in this case, y equals 2. That is the only case where y equals 2. Here, y equals 2, y equals 3, y equals 4, y equals 3, y equals 4, y equals 5, y equals 4, y equals 5, y equals 6. This is the only time y equals 2. So the probability y is 2 is just the probability of this, which is 0.04. The probability y is 3 is this trial or this trial. The probability y equals 3 is this trial or this trial. The reason I'm enunciating the or is because we need to add these. So therefore, the probability of getting a 3 is 0.2. Probability y is 3 is 0.2. Why is that? Because the probability is this trial, or this trial. Excuse me, guys. Excuse me. Excuse me. I apologize for that. I must be allergic to something. Anyways, let's keep on going. Now, y could equal 4. In this case, y equals 4. Or in this case, y equals 4. Or In this case, y equals 4. So the probability of y equaling 4 is this case, plus this case, plus this case. 0.06 plus 0.25 plus 0.06 is 0.37. The probability y equals 5 is this or this. This or this. So I need to add 0.15 plus 0.15 is 0.3. And finally, the probability y equals 6 is only this one. There is no other trial. Let me zoom out for you. There is no other trial where the sum of the two numbers is 6. This is the only option. This is 0.09 here. And then you can find the expected value for y by putting this into list 1. This goes into list 2, and you get 4.2. But I want to zoom out again. And all I did here is I said, what are the possible outcomes for drawing two x's? Like get a 1, 1, 1, 2, 1, 3, blah, blah. I found the probability of each one. These were found using multiplying because it's 1 and 1 again. 1 and 2, 1 and 3, and so on. And then I said, what could y be? Right? And then I added the different possibilities. Like, for example, if I want to know where did this come from? Y equals 3. The probability is 0.2. Well, these are the two options. So I added 0.1 and 0.1 to get 0.2. Let me zoom out and call it a video.